Now we've looked a bit at IP version 6 addressing, let's go ahead and look at some of the reserved ranges of IP version 6. Now, one thing to keep in mind about these reserved ranges is they aren't so much reserved ranges as they are reserved special purpose IP addresses in the IPv6 group. The first one we want to look at is something called the unspecified IPv6 address. The unspecified IPv6 address is shown as all zeros in the boundaries or simply as a colon. Effectively, this is an IP address that's basically 128 zeros. The use of the unspecified IPv6 address is to indicate the absence of an address. This is the equivalent of the IP version 4 unspecified address 0.0.0.0. This is used as the source address for a packet that needs to verify the uniqueness of a tentative address it is trying to reach. One caution about the unspecified IP version 6 address is you should never assign it as an interface or use it as a destination. Next, we want to look at the loopback address. In IP version 6, the loopback address is shown as all zeros in the first 7 boundaries and a 1 in the last boundary, or simply a ::1. This is effectively an IP address that has 127 zeros with a single 1 in the 128th bit location. This is used in IP version 6 to identify a loopback interface, which, just like in IP version 4, allows a node to send a packet to itself. The equivalent IP version 4 address would be the 127.0.0.1 that we looked at previously. Packets addressed to the loopback must never be sent to a link or forwarded to a router. The next group of addresses we want to look at are called compatibility addresses. Compatibility addresses are used to aid in the migration from IP version 4 to IP version 6. These are often used to allow both IP version 4 and IP version 6 hosts to exist in the same network. In fact, when a computer has both IP version 4 and IP version 6 protocols running on it at the same time, this is called a dual IP stack. We'll look at dual IP stacks in a little bit more detail later. The first compatibility address we want to look at is the IPv4 compatible address. IPv4 compatible address is shown as zeros in the first 6 boundaries with a w.x.y.z in the 7th and 8th boundaries. Or another way to express it is a w.x.y.z. As you may have guessed, the w.x.y.z represents any public IP version 4 address. Now keep in mind this is a public IP version 4 address, not a private IP version 4 address. This means that we can only use IP version 4 addresses in this location that are able to get on the internet. The place an IP version 4 compatible address is used is by IP version 6/IP version 4 nodes that are communicating using an IP version 6 infrastructure. Now, an IPv6/IPv4 node simply indicates that both IP version 6 and IP version 4 protocols are running on the same node, or, as I said previously, a dual IP stack node. The IPv4 compatible address is automatically encapsulated with an IPv4 header even though it's running on a computer running IPv6. This makes it possible for the packet to be sent to its destination using the IPv4 infrastructure. IPv4 mapped addresses are another compatibility address I'd like to look at. IPv4 mapped addresses are shown as zeros in the first 5 boundaries, with all F's in the 6th boundary and w.x.y.z in the 7th and 8th boundary, or simply as : FFFF:\w.x.y.z. Effectively, what this means is this is an IPv6 address that has all zeros in the first 5 boundaries, but the 6th boundary has all ones, and then the 7th and 8th boundary has an IPv4 address. This type of address is used to represent IPv4 only node to an IPv6 node. A IPv4 mapped address should never be used as a source or destination address for an IPv6 packet. The 6 to 4 address is used to communicate between two nodes which are both running IPv4 and IPv6 over an IPv4 routing infrastructure. The 6 to 4 address is formed by combining the prefix 2002 :/16 with the 32-bit address of the public IPv4 address of the node that's being communicated with. The result is a 48-bit prefix which is then used to define the connection on the IPv4 routing infrastructure. 6 to 4 tunneling is described in more detail in the RFC 3056. Also, when we talk about tunneling, we are talking about the process of establishing a connection through a public network. Tunneling connections look like point-to-point connections to the devices on either end of the tunnel. However, even though the connection looks like a point-to-point connection, in reality it is not one. Next, I'd like to talk about ISA-TAP address. ISA-TAP addresses are used between two nodes running both IPv4 and IPv6 over an IPv4 routing infrastructure. ISA-TAP addresses use the locally administered interface ID of ::0:5EFE::w.x.y.z. In this case, the w.x.y.z can be any unicast IP version 4 address. What this means is both public and private addresses can be used in an ISA-TAP address. This is different from the previous ones we've talked about, which were all limited to just public addresses. The ISA-TAP interface ID can also be combined with any valid 64-bit IPv6 address. This includes local link address prefixes that have an FE80:/64 prefix, site local prefixes, and even global prefixes so long as they all use the /64 prefix of an IPv6 address. We'll look at global, local link, and site local addresses in more detail later so we have a better understanding of exactly what these things are. Finally, we want to look at Teredo addresses. Teredo addresses use the prefix 3FFE:831F:/32. Teredo addresses are used to represent hosts when using automatic tunneling mechanisms as defined in the Internet Draft Teredo tunneling IPv6 over UDP through NAT. Beyond the first 32 bits, Teredo addresses are used to encode the IPv4 address of a Teredo server. If you'd like to learn more about IPv6 addresses as well as the different reserved addresses in the IPv6 protocol, then this website here is an excellent source for additional information.